Okay, in this video, I'm going to go through the lab today on the prime numbers. Okay, so I want to make sure we understand that. So let me go ahead and share the screen. Actually, let me share everything just in case there's a pop-up, which there probably will be. Okay, so the idea behind this one is that we're going to do prime numbers less than 1,000. You can go up to 1,000 or not. 1,000 is clearly not prime because it's divisible by 10 and 2 and lots of other things, 5. So anyway, so that doesn't really matter. Okay. So my recommendation was that we start by figuring out how to do a prime evaluation for some number. Okay. So I'm just going to set my n initially equal to 7. Okay. So then to test this, I'm going to have to do, I'm going to use C for my counter in a range. Okay. Everything's divisible by 1, so I don't need to start there. So I'm going to go ahead and start at 2. Okay. And I want to go up to 6. So I can go ahead and say n there because that's going to get us the right range. Okay. And I can, again, just to verify that this is working, go ahead and print this, run this here. Okay, 2, 3, 4, 5, 6. Yeah, that's good. Okay. So now the general, and again, we're going to replace this with a loop to go through all the numbers, but for right now, that's going to be enough. Okay. So the way we're going to do this, we're going to start by setting an is prime Boolean equal to true. Okay. So we're making the assumption to begin with that the number is prime. Okay. Then as we go through, if we find that it's not prime, okay, so if there's an issue, and what we're going to test for here, this C that starts with 2, I'm going to say if n, which is the number I'm checking, mod C is equal to 0. So what that's saying is if I take for whatever C that I have, okay, let's do a different number here. Let's do 4. Okay. So the very first value of C is going to be 2. So this is going to say if 4 mod 2 equals 0. 4 divided by 2 gives you a remainder of 0 because 2 is a factor of 4. So this is going to be true. Okay. So then the is prime is false. Okay. So I can start with this one. This will fail right away. Okay. And if you want at first, just to check yourself here, you can just say print star, star, star. It doesn't matter what you print. C. Okay, so just so we can see the count and we kind of know where that happens. Okay. So if we run this one, okay, we should see that we're not being very efficient here, that it's checking for 2 and it's checking for 3. Okay, I entered 4, that's all it's going to check. Okay. And furthermore, we can go ahead and print out here is prime. Okay, in fact, let me print these. Move this here. And again, you wouldn't have to do this. This is test code, but it's not a bad idea. Okay, so if I move this to here, we can kind of see what's happening here and see that is prime is false at this point. Okay, so to make sure this is working, I can change this to something like 9. 9 should have 2 being true and then the rest being false, because once it's false, it stays false. Okay, so that should be okay. Yeah, so it looks like that's working. Okay, so that should be fine. So then there's the printout that I do want here. I want to only, again, I'm printing the prime numbers here. So if is prime is still true, okay, and I don't need to say equals true because it just is true. If is prime, then I'm going to print. I'm going to put a tab to make it look a little nicer, but you don't have to. And then I'm going to print that particular, the number that we're on. Okay, so that is n we're dealing with. Okay, so you don't have to worry if it's not. This should be fine. So let's try some of these. Okay, this should print out. It is not. not going to be a prime, which is correct. But I believe 19 is a prime. Yep. Oh, interesting. I'm printing in the wrong spot here. I'm printing inside that loop because it's printing it every time. Okay, so this print, in fact, this whole if needs to come out to there. Okay, that should just print it one time. Yeah, looking better. Okay, so now that I've got this working, and this is gonna, it's this whole bit of code that checks to see if a number n is prime. Okay, so instead of having a number here, I can put a loop, say for n in range. Again, I'm going to start at 3. Okay, let's just go up to 11. Okay, just so our printout's not so long, we kind of see what's happening. Okay, I have to indent that, have to indent that, that, and that. Okay, and this should print out 3, 5, 7. That should be it. Let's see. 3, 5, 7. We're good. Okay. So let's go ahead and put a little message here. Let's say print primes less than 1,000. Okay, then I can change my range here to 1,000. You can do 1,001 to make sure that's verified. That's fine. Now, if I run this, this should go down, print out a whole bunch of numbers. Okay. You should see no even numbers. You should see, remember, you can add numbers up, add the digits up to see if they're divisible by 3. So again, I know that 811 is not divisible by 3 because if I add 8 and 1 and 1, I get 10, not 9. Okay. So it looks okay. I didn't ask you to do this, but you can go ahead if you wanted. We can count the number of primes are less than 1,000. Okay, so I can start off before I get anywhere, setting my count equal to 0. And now, yeah, it's not going to work. Is it? Oh, yeah, it is. It's going to work. It's going to be okay here because I can now, I was going to say I can't, it could be false more than once. Okay. So here I can let count be equal to count plus 1. Okay. And then when everything's done, I can print there were count primes less than 1,000. Okay, I have to do a little work to see if that is actually accurate, but see what that does. Okay, there are 167. That seems reasonable. Okay. The other thing we could have done, if you wanted to make things a little more efficient, again, this is all optional. Okay. The first thing I can do here is that any number can't, if you go up to the square root of n, you don't have to go any further. Okay, so I can do here in, I think I have to do an int. I'm going to convert to an int in star 0.5, raise it to the half power. Okay, that should work, should give us the same results unless something weird happens. Yeah. Yes. Oh, 185. That's not good. Something wrong happened there. So I would have to see what's going on. But yeah, it really shouldn't have changed it. I'm not sure what that's doing, but that will make it run more efficiently, but doesn't really matter about that. Yeah, that is quite curious. Okay, so I can just do that. That's okay. But the other thing you can do in your loop here, I could turn this into a while loop if I wanted to exit whenever is prime becomes false. Okay, or a command we don't know yet, but some of you found anyway. I can do a break. Okay, and what a break's going to do is as soon as it hits the break, it's going to exit the loop that it's in. Okay, so it's going to exit that for loop. Okay, and you're not going to see that it should run just the same, but know that it is going to run less. Okay, let's see which number I get this time. 167. Yeah, I don't know why I got more that time. I'd have to investigate that. I was causing some odd thing to happen. Okay. I guess I could set some other variable here. Yeah, it's not worth messing with. But anyway, that's the basic idea of how this works. Okay, it's a fairly short program, but there's a lot going on here. Okay, so if you have questions about this, make sure that you let me know.